Welcome to the second module of the VBlock System Foundations training. In Module 1, you learned about the basic technology and components used in VBlock systems. The focus here is on the VBlock system platforms. In this first section, you'll receive an introduction and overview of all of the platforms. This will be followed by several sections providing more detail about each of the 4 VBlock system platforms. At the conclusion of this training, you will be able to identify the VBlock system platform families and identify customer situations and needs suited for each VBlock system family. In addition, you'll be able to use the VCE VBlock Systems Release Certification Matrices to identify current VBlock system component models.
VCE is a cloud computing and converged infrastructure pioneer. We are a company that helps customers around the world simplify and accelerate deployment of cloud computing by integrating state-of-the-art technology from Cisco, EMC, and VMware. The VBlock system is the industry's first completely integrated offering for cloud computing. VCE's converged infrastructure represents a new direction in information technology and enables organizations to deliver IT faster, more reliably, and at lower cost than is possible with traditional data center models. VCE's history began on November 3, 2009, when the leaders of EMC, Cisco, and VMware announced an unprecedented collaborative effort designed to help customers increase business agility and lower costs through a transition to cloud computing and pervasive data center virtualization. The coalition brought together industry-leading IT infrastructure to deliver to a customer a single entity through the newly created VCE. The introduction of the first VBlock systems and converged infrastructure in 2010 provided a fundamentally better approach to streamlining and optimizing IT strategies around cloud computing. Demand for VBlock systems grew instantly and have been popular with customers since. Today, industry surveys show cloud computing is one of the top information technology trends, and VCE continues to lead the transformation to cloud with converged systems that virtually eliminate the complexity that is inherent in traditional data center architectures. VBlock systems are the world's most advanced converged infrastructure. They represent the next evolution of IT, one that unleashes simplicity by delivering the extraordinary efficiencies of business agility and virtualization in cloud computing. Seamlessly integrating best-in-class compute, network, and storage technologies, VBlock systems provide dynamic pools of resources that can be intelligently provisioned and managed to address changing demands and fleeting business opportunities. The VBlock system portfolio is built on a single, highly secure, standardized, market-leading infrastructure. All VBlock systems are pre-integrated, tested, validated, and capable of being quickly deployed, easily distributed, and counted on to increase system performance predictability and timeliness of IT project completion. Through VBlock systems, VCE delivers the industry's only fully integrated and fully virtualized cloud infrastructure system. The VBlock system consists of products across 4 families, which span a tremendous range of IT functionality. From the smallest VBlock System 100 family to the largest VBlock System 700 family, the infrastructure is the same, the predictability is the same, and the ability to get up and running quickly is too. In terms of both implementation and performance, VBlock systems are highly predictable. In a fast-paced world where priorities are constantly churning and shifting, IT predictability is a significant business advantage. Let's introduce each of these VBlock system families one at a time. The VBlock System 100 is the smallest of the platforms, offers exceptional IT performance. It is right-sized IT delivered efficiently so customers can respond to their less demanding business needs and opportunities with the same advanced, converged infrastructure technology used for situations demanding greater capacity. The vBlock System 100 provides the world's most advanced converged infrastructure, scaled to address the needs of mid-sized data centers as well as remote and distributed operations. Customers can choose from two models, which can be installed anywhere from data center environments to a computer closet. Both are ideal for organizations that already own vBlock systems and want to simply and efficiently address specific workload and capacity requirements, while ensuring the standardization, repeatability, and business agility of the vBlock systems family. Do you think customers ever need to get up and running fast? vBlock System 100 comes pre-configured, tested, and validated, so they can be delivered in as little as 4 weeks and operational within days, providing amazing time to value. Like all vBlock system models, this converged infrastructure tightly integrates world-class components from Cisco, EMC, and VMware, providing an ideal solution for distributed operations in healthcare, advanced manufacturing, and other global businesses. System management is greatly simplified with the help of VCE Vision Intelligent Operations software, which has native integration with key VMware management products, as well as customers' choice of leading third-party management tools. In addition, VCE support provides one-call resolution of most issues. The basic components of the vBlock System 100 include Cisco C-Series rack-mount servers and EMC VNXE storage. The vBlock System 100 was designed from the outset to simplify and transform ordering, fulfillment, and delivery processes, provide improved performance, decreased management complexity, and a simplified support model. Fast-growing, mid-sized businesses require increased flexibility to meet rapidly changing needs. The vBlock System 200 provides advanced converged infrastructure in a variety of configurations that are ideal for virtualization and cloud computing. vBlock System 200 delivers power and capacity for core IT services from file, print, and domain to a virtual desktop infrastructure, VDI, or real-time collaboration. And it has room for expansion. Businesses move fast, and this system supports that. vBlock System 200 can efficiently handle any mixed workload requirement in a mid-sized data center. The vBlock System 200 comes pre-configured and validated so it can be up and running in as little as 30 to 45 days after order with minimal risk. The converged infrastructure is tightly integrated to provide unmatched data center versatility and business value. Customers can focus more on increasing organizational productivity and innovation in pursuit of a competitive edge. Like the vBlock System 100, system management is greatly simplified with the help of VCE Vision Intelligent Operations software. And like with all vBlock system products, VCE support offers responsive, one-call resolution for virtually all issues. The basic components of the vBlock System 200 include Cisco C-Series rack-mount servers, Cisco switches, and EMC VNX storage. Cisco UCS C-Series rack servers ensure exceptional performance and availability across a variety of applications. In addition, EMC VNX unified storage systems are optimized for virtualization and support Fibre Channel in addition to other network technologies. The vBlock System 300 family with enterprise-class performance is ideally suited to achieve the scale needed for large virtualization and cloud implementations. Engineered and validated to address a broad spectrum of workloads, the vBlock System 300 family offers growing businesses a range of choices to satisfy varied performance and capacity specifications. At the same time, built-in capabilities significantly enhance operations and management simplicity. Designed for dynamic environments, the vBlock System 300 family enables customers to adapt to continuing growth and change. Leveraging the system's enhanced versatility in dynamic pools of resources to quickly and intelligently provision infrastructure as needed. The VBlock System 300 family is designed to run a wide range of mission-critical applications in rapidly growing enterprises. This includes core data center services, mixed workloads such as SAP, Oracle, and Microsoft Exchange, demanding databases and business continuity or disaster recovery solutions. A unified data center fabric and choice of segregated or unified networking within the VBlock System 300 enables customization of system capabilities with business requirements. This can be highly cost-effective as customers rely on cloud computing to run more of their business. The VBlock System 300 family incorporates the Cisco B-Series blade servers and the proven and trusted EMC VNX series storage arrays. This unified storage is optimized for virtual and cloud computing applications, supporting a variety of RAID configurations for the highest availability. In addition, VBlock data protection safeguards critical information and applications with an exceptional suite of data protection solutions. The VBlock System 700 family, the largest and most capable of the platforms, is comprised of enterprise and service provider class systems designed to help organizations benefit from virtualized and cloud computing faster and easier. These systems are designed for mission-critical application environments, offering the highest level of data and application availability. It provides powerful and highly flexible storage, unprecedented configurability, dynamic and intelligently managed pools of resources to efficiently address the most demanding, mission-critical applications. The VBlock System 700 offers great flexibility to quickly meet any workload and service level requirements. Pre-integration and validation at the factory typically enables VBlock System 700 to be delivered within 45 days, with deployment in as little as a week. The VBlock System 700 offers more performance and scalability to support the largest cloud environments, running thousands of virtual machines. Mixed storage using the EMC Symmetrix VMAX family provides more choices and delivers up to double the storage performance. The VBlock System 700 family has been engineered to provide outstanding performance and responsiveness for the most demanding mixed workloads. These may include SAP or Oracle Enterprise Resource Planning, or Customer Relationship Management applications, Microsoft Exchange or SharePoint, vast virtual desktop infrastructure environments, and other mission-critical applications. For customers, the highest security and availability are musts. The VBlock System 700 family delivers uncompromising availability to ensure that core IT services are available when needed. In addition, the system incorporates the latest security protections to reduce risk. The basic components of the VBlock System 700 family includes Cisco B-Series blade servers, Cisco Nexus and MDS switches, and built for the data center EMC VMAX storage systems. The last category of VBlock system families is VBlock specialized systems. This family of products targets enterprise-level applications with VBlock system architecture customized and optimized to deliver a specific capability. Like all other VBlock systems, the VBlock Specialized System represents best-of-breed compute, network, and storage components from Cisco and EMC. New specialized systems will be continually developed over time in response to customer needs. Currently, VCE has 3 offerings: VBlock Specialized Systems for SAP HANA, VBlock Specialized Systems for Extreme Applications, and the VBlock Specialized System for High-Performance Databases. VCE will continue to develop more specialized systems in the future. Click and review each tab for more information on each of these specialized systems. SAP HANA software is the centerpiece of SAP's entire new data strategy. For SAP users, the question is not whether they will move to SAP HANA software, but rather when. SAP long-term application infrastructure strategy is predicated on an entirely new platform design to leverage advances in server technology, in-memory databases, and cloud computing. The primary advantage of an in-memory database comes from the fact that it operates from inside the host server's memory, instead of from storage flash or disk drives, which are both slower. Also, it allows for the scaling of many multi-tenant type environments on a single database, eliminating the need for different types of databases for different application needs. What customers need is what VCE VBlock Specialized System for SAP HANA provides: the highest level of availability and application performance for SAP HANA solutions. VCE eliminates significant risk by providing a fast and predictable SAP HANA deployment. In addition, it is engineered with optimized best-of-breed components, and it is certified by SAP. VBlock Specialized System for Extreme Applications brings the benefit of the world's most advanced converged infrastructure to meet the demands of the most extreme applications. What makes it different is a flash-based storage array that delivers the extraordinary performance required for massively scalable virtual desktop infrastructure implementations and similar solutions, while dramatically lowering costs and enhancing the user experience. Data storage is based exclusively on the EMC Extreme I/O random access flash media, ensuring unparalleled performance in the millions of IOPS with sub-millisecond response times. This enables users to enjoy fast boot-ups, logins, and simply better application access than with traditional enterprise storage solutions. In terms of benefits, it is extremely cost-effective. A space-efficient footprint and significant power and cooling savings are just part of what makes this flash-based VBlock system so cost-effective. Innovative inline deduplication for greater consolidation drastically decreases storage capacity needs, while full clone flexibility reduces your administrative chores. Also, it is right-sized from the start. Addressing issues such as VDI sizing to support SLAs can be a challenge for any data center manager. But customers' VDI applications will be pre-integrated, tested, and validated before the system arrives on their shipping dock. And finally, it reduces complexity. Not only is setup effort minimized, but professional services and support from VCE is available to streamline implementation, and VBlock Data Protection provides a full suite of available integrated solutions for backup and recovery, automated replication, and workload mobility. VBlock Specialized Systems for High-Performance Databases extends the world's most advanced converged infrastructure to large enterprise databases such as Oracle. This new architecture delivers high performance and scalability for continuous availability of mission-critical database-dependent applications. It supports single or multiple databases as well as specific mixed workloads. Custom-built for specific business needs, it is engineered and optimized for high-volume online transaction processing or online analytical processing, as well as point-of-sale transactions, legacy applications, and enterprise business intelligence or data warehousing. Performance can be scaled to millions of IOPS with millisecond latencies for blazing throughput. The system provides unmatched flexibility by consolidating mixed databases and applications. Production, QA, and test development environments can be run simultaneously. The VBlock system's modularity scales as needed. Compute, storage, and network virtualization drives costs dramatically lower, and fewer cores can reduce both operations and licensing expenses. For continuous operations, choose from a complete portfolio of integrated data protection options for continuous availability to support key business objectives or to meet the most stringent service level agreements. You'll learn more of the details of each of the VBlock system platforms in the next few sections. But for now, to realize the differences between the size and capabilities of these systems, here is a snapshot of the VBlock system platforms. First, as you know, VBlock systems have platforms that offer rack mount servers or blade servers. Note that the smaller capacity VBlock System 100 and VBlock System 200 come with Cisco C-Series rack mount servers, while the VBlock System 300 and VBlock System 700 families are equipped with Cisco B-Series blades. Remember that rack mount servers connect directly to the VBlock system's network switches, while the blade servers come in a system that includes blade servers' chassis and fabric interconnects. Blade servers, while more costly to purchase than rack mount servers, are easier to manage because the Cisco UCS Manager is installed on the fabric interconnects. This single logical instance of the Cisco UCS Manager manages all servers connected to the fabric interconnects. With the Cisco rack mount servers, there is no fabric interconnect, and SIM-C is installed on each server, and each server is managed independently. Notice the compute capacity differences between models. These will change over time, but the relative differences between models is worth noting here. Compute capacities range from a maximum of 8 servers in the VBlock System 100 up to 384 in the VBlock System 700 family. There are important differences to note in network capabilities as well. The VBlock System 100 offers only a LAN. This supports Ethernet only, and block-level storage is made possible using the iSCSI protocol. VBlock System 200 has a unified network, which uses unified network switches with both Ethernet and fiber channel ports, which provide LAN and SAN capabilities. The VBlock System 300 and VBlock System 700 families offer either segregated network or unified network. Segregated networks have separate LAN and SAN switches, while unified networks utilize unified switches with both Ethernet and fiber channel ports. The storage capacity across the VBlock system families also covers a wide range. The VBlock System 100 comes with a lower capacity EMC VNXE product. The EMC VNX family offers many models that offer varying capacity across both the VBlock System 200 and VBlock System 300 families. And finally, the EMC VMAX products, offering tremendous storage capacity, is part of the VBlock System 700 family. And finally, to demonstrate the relative differences in size of the systems, notice the differences in the maximum number of cabinet enclosures for each of the systems. These range from 1 for the VBlock System 100 up to 28 cabinets for the VBlock System 700. A significant distinction between VBlock systems and traditional data center models is how quickly VBlock systems are delivered and deployed. Traditional data center resources can take anywhere from weeks to several months to deploy. Creating these systems and taking them from concept to production is no small undertaking. It requires sizing of the applications to determine the system's compute, network, and storage components to purchase. Once sizing is known, the requirements are shopped to multiple vendors to find the most cost-effective option. Multiple orders of parts get placed to various suppliers, and waiting begins. Some of the components will arrive on time. Some will be back-ordered. And finally, when everything has been received, the installation begins. Racks are installed, assuming there is adequate floor space, and the components are unpacked, racked, stacked, and cabled. With everything properly assembled, the system is powered on, hopefully with no failed components. Now components are configured to the appropriate software and firmware versions. Then system testing and validation takes place before the system is finally ready. Contrast that process with the purchase of a VBlock system. It is ordered. It arrives fully assembled as a ready-to-deploy appliance. Within a matter of hours or days, the system is in full production, processing real workloads. International Data Corporation, IDC, is the premier global provider of market intelligence in the information technology, telecommunications, and consumer technology markets. IDC helps IT professionals, business executives, and the investment community make fact-based decisions on technology purchases and business strategy. IDC conducted in-depth interviews with 11 IT organizations, enterprises, and major service providers that deployed VCE VBlock systems. IDC found that VBlock system implementations sped deployments, simplified operations, improved business support agility, saved money, and freed staff to launch new applications, extend services, and improve satisfaction. This white paper provides a concise overview of the changing needs of IT management and how VBlock systems dovetail with these needs. You've learned in this training that VBlock systems represent advanced converged infrastructure technology that is changing how IT services are managed. VBlock systems are complex engineered products. But the difference between VBlock systems and other systems is that VCE makes this complex technology easy for customers to purchase, deploy, and maintain. VCE does all of the hard work of thoroughly testing each component and certifies that all components and the software and firmware they use are compatible. This is a significant benefit to businesses who can avoid the time and resource-intensive tasks of testing each component of their IT systems. With this in mind, one of the tools VCE provides to customers is the VCE VBlock System Release Certification Matrix, or RCM. VBlock system components and their model numbers are changing all the time. For customers who want to upgrade components, the VBlock System Release Certification Matrix is a great reference. It details for each component its compatibility with the rest of the customer's VBlock system. We'll be discussing details of the VBlock system platforms in the remainder of this training. However, this training will not teach you about specific components and their model numbers. Component model numbers change frequently, and it would be impossible to keep current here. Instead, we'll focus on product families like the Cisco UCSC series servers and Cisco B-series servers. You'll learn about the basic features and general capabilities of each component family, and we'll teach you to refer to the matrix for details. On this page, there are links to the locations where you can get copies of all current release compatibility matrices. Note that there are different locations for VCE customers, partners, and employees. In the example screenshot of the Partner Portal, notice the section labeled Release Certification Matrices. Notice that there are links to all of the VBlock system platforms here. When you click on one, for example, VBlock 300 family, a list of all of the available RCMs appears. There are several sections to each certification matrix document, and we'll highlight a couple here. First is the Certification Matrix Purpose Statement. Displayed here is the purpose statement for the VBlock System 320 Release 4.0.3 Certification Matrix. This provides a list of all of the components that have been upgraded as part of the 4.0.3 release. For a customer to upgrade their VBlock System 320 from its current release to the 4.0.3 release, they must upgrade all of the components listed here. For example, the VMware vSphere Hypervisor ESX ESXi 5.1 must be upgraded to version 5.1 Patch 2 Build 1157734 as part of the upgrade to the VBlock System 320 4.0.3 release. Each currently available component and its model number are listed in the Base Components section of the matrix. For example, you can see here that the VBlock System 320 Release 4.0.3 uses Cisco UCS B-Series blade servers in its compute. Also listed here are the specific model numbers of the Cisco UCS B-Series blade servers that customers can choose from. These include the B200M3, the B220M3, the B230M2, the B250M2, the B420M3, and the B440M2. These are all versions of the Cisco UCS B-Series blade server family, and they vary by the number of CPUs, CPU speed, amount of memory, or other characteristic. As mentioned earlier, this training will not teach you about the current component model numbers used in the VBlock systems, because these change frequently, making it impossible to keep current. Instead, we'll discuss product families and reference the matrix for details.
This is a learning check that provides an opportunity for you to assess your progress. Each question provides feedback to help you remember the content, and a score is provided at the end so you can assess how you are doing. This is not a test and is not part of the certification assessment. Learning check scores are not retained in your records. However, completing these learning checks is great preparation for the certification assessment that comes later. You may take this learning check as many times as you want. Click Next to get started.
You've completed the high-level introduction to the VBlock system platforms. In this section, you learned about the 4 VBlock system platform families and the VBlock specialized systems. You've also learned about the VBlock system's release certification matrices and how to identify current VBlock system component models. In the next few sections, you'll learn more about each of the VBlock system platforms. Welcome to the introduction to the VBlock System 100. You've learned a lot about the basic technologies of the VBlock system, and you have completed an overview of the VBlock systems. It's time now to take a closer look at each of the VBlock system platforms. We'll begin with the VBlock System 100. Upon completion of this training, you'll be able to describe the VBlock System 100 relative to the other VBlock system platforms. You'll be able to identify the typical use cases for the VBlock System 100 and identify and compare the 2 VBlock System 100 models. You will also be able to describe the difference between the general purpose and the performance configurations and identify the VBlock System 100 basic components that constitute the compute, storage, networking, and virtualization technologies.
The VBlock System 100 is the smallest VBlock system in terms of size and capacity. It targets IT needs that don't require the power and capacity of larger VBlock systems. But don't be fooled by the VBlock System 100 size. Like all other VBlock system models, it is an enterprise IT system built on the same converged infrastructure technology. The VBlock System 100 provides a simplified, standardized infrastructure and operational process with predictable performance and operational characteristics, right-sized to meet customers' workload, power, and space requirements. VBlock System 100 provides an entry point into a cloud appliance platform. It provides the world's most advanced converged infrastructure, scaled to address the needs of remote and distributed operations, as well as mid-sized businesses. Following the building block approach, VBlock System 100 is pre-built. Its components are racked, stacked, cabled, configured, and tested to create a shippable appliance that does not require customer assembly. As with all VBlock systems, the VBlock System 100 uses components from Cisco for compute, LAN networking, and SAN networking, as well as components from EMC for storage. Virtualization is provided by VMware. This system is facilities-friendly, easy to deploy, and it enables seamless integration into larger IT environments, especially those with existing VBlock system installations. Although targeted at remote office and branch office deployments, the VBlock System 100 is also ideal for enterprise departmental applications and can be implemented as an IT solution for whatever purpose the customer chooses. The VBlock System 100 is engineered for simplified IT operations for remote and branch offices. Not only does it offer rapid deployment of consistent business services across distributed locations, but it provides easy centralized management and support of local and remote systems. VBlock System 100 is an ideal system for branch or remote offices, organizations with multiple data centers, and those needing development or test systems. It is well suited as a DMZ in a cabinet, where a company can make certain systems available to networks facing outside of the company without exposing other critical systems. The VBlock System 100, purchased as a standalone IT system in a box, can be easily deployed for this purpose. A VBlock system is pre-configured hardware and software that is engineered and validated to operate as a single unit. Physically, the VBlock System 100 is the smallest VBlock system. It comes in 2 configurations that you'll learn more about in a moment. The VBlock System 100BX is the smaller configuration, and it comes in a 24 RU cabinet, which measures 49 inches in height. A second configuration, the VBlock System 100DX, is almost twice as tall at 42 RU, or about 80 inches high. Note that the weight and power requirements also differ. This table provides component details and illustrates the differences between the BX and DX models. Note that this information is accurate at the time this training was published, but This information can change at any time as the product evolves. Nevertheless, it is useful to review it now as it demonstrates the differences between the VBlock System 100 models. You already learned how these models differ in size, and as you probably expect, they differ in capacity as well. The BX has a base compute configuration of 3 Cisco UCX C-Series rack-mount servers, but can contain a maximum of 4. Each server has 64 gigabytes of RAM. The Model DX starts at 3 and offers configurations up to 8 rack-mount servers, each with 96 gigabytes of RAM. The other components are consistent across the BX and DX models. They both contain 2 Cisco Catalyst LAN network switches that provide Ethernet capability, but do not provide Fibre Channel SAN connectivity. Unlike all other VBlock systems which use Fibre Channel for block-level storage, the Catalyst LAN switches provide access to block-level storage using the iSCSI protocol over Ethernet. Both VBlock System 100 models use EMC VNXE storage, vSphere Enterprise Plus, and VCE Vision. Both models also come in general and performance configurations that you will learn more about in a moment. In terms of connectivity, the compute consists of Cisco C-Series rack-mount servers. These are connected directly to Cisco Catalyst LAN switches, which have only Ethernet ports. While these are not unified switches, they do provide both connectivity to the customer site network and to the system storage. It's important to understand that the VBlock System 100 network switches have no Fibre Channel capability to support SAN. Therefore, there is no SAN in a VBlock System 100. VBlock System 100 servers still boot from block-level storage over a network, but they do so through the LAN switches over Ethernet using the iSCSI protocol. File-level storage as well as site network connectivity is provided through the LAN switch. Note that the file server functionality needed for file-level storage is built into the storage processor. All other VBlock systems utilize separate file servers for file-level storage.
Now, starting with storage, let's dive a little deeper and review the specific components that are used in the VBlock System 100.
This table shows details about the VBlock System 100 storage components. Each model contains 2 VNXE arrays with either all SAS drives or a combination of SAS and nearline SAS drives. For connectivity, each array has 2 I/O slots. Each VNXE contains 2 storage processors, but the BX has 8 gigabytes of memory in each storage processor, while the DX has 12 gigabytes in each processor. The VNXE uses the iSCSI protocol for block-level storage and offers CIFS and NFS protocols for file-level storage. Both the model BX and DX come in 2 storage configurations, and the difference between them is in the type of storage drives used in the EMC VNXE. The general or capacity configuration is designed for capacity-intensive sequential reads, so the VNXE contains both SAS and nearline SAS drives. The nearline SAS drives are approximately 3 times the size of SAS drives, and due to their size and other design characteristics, they require greater seek time and produce slower data transfer rates. The performance configuration, designed for performance-intensive random reads from storage, contain only the faster SAS drives. The SAS drives require less seek time than the nearline SAS drives, and therefore offer better overall data transfer rates. At the time this training is being published, there are 2 VBlock System 100 models that each have both general purpose and performance configurations, designated by a G or P in the configuration name. Most notably, the general configurations use a combination of SAS and nearline SAS drives, while the performance configuration utilizes only SAS drives. The VBlock System 100 BX model comes in 2 configurations, the 100BX-3G, which is the general configuration, and the 100BX-3P, which is the performance configuration. Note that the 3 in the name refers to the number of compute servers each contain. The same designation conventions apply to the model DX. General configuration models end with a G in the name and contain both SAS and nearline SAS drives. Performance model names end with a P and contain only SAS drives. The standard configurations of the DX models come with 3, 6, or 8 compute servers. VBlock System 100 offers 2 types of physical drives as described in the preceding page. RAID 5 and RAID 6 protection levels are available for host-accessible LUNs. RAID 5 and RAID 6 are both parity configurations. Recall that parity is a method of protecting striped data from disk failure. A portion of each stripe is dedicated to storing information calculated from the rest of the stripe, so that if a drive fails, the missing data can be calculated and recreated. The 2 parity RAID types used in VBlock systems are RAID 5, where one portion of each stripe is dedicated to parity on a single drive, and RAID 6, where 2 equal portions contain complementary parity on 2 separate drives, so that recreation can be performed even if 2 drives fail before the recreation completes. The extra drives increase the cost of RAID 6 over RAID 5, but provides additional protection in the event of 2 drive failures. RAID 6 is most often used with nearline SAS drives, which have longer rebuild times than SAS drives. This is important because when a parity-protected drive fails, the data from it is rebuilt on a spare drive. The longer that the rebuild takes, the higher the risk that there will be an additional drive failure before the rebuild completes. Rebuild times are dependent on drive size and drive speed. In RAID 5, if one drive fails and is in the process of being rebuilt when a second drive fails, data will be lost. With RAID 6, a second drive can fail without losing data. Each disk processor enclosure, or DPE, and disk array enclosure, or DAE, in a VBlock System 100 model DX can hold up to 12 drives. Remember that a DPE is the same as a DAE, except that it contains storage processors in addition to disk drives. All VBlock System 100 model BXs contain a single DPE that holds a maximum of 12 drives. In addition to a single DPE, each VBlock System 100 model BX can have up to 2 DAEs. These can hold up to 12 drives and can be a performance DAE or a capacity DAE. Similar to the VBlock 100 BX models, the VBlock 100 DX models enclosures come in either a performance or capacity configuration, with hot spares available as an added protection against drive failure. The main difference is with the number of devices that can be installed in the disk enclosures. The VBlock 100 DX uses a 15 disk drive enclosure for its storage. The enclosures also differ in how the drives are installed. Disk drives are installed horizontally in the VBlock 100 BX model and vertically in the VBlock 100 DX model. All VBlock System 100s have 1 DPE. However, the number of DAEs found in each standard configuration varies from 0 DAEs up to 5 DAEs. Note that the total DAEs in a configuration equals the number of capacity DAEs plus performance DAEs. While the EMC VNXE used in the VBlock System 100 are the smallest of EMC storage products in any VBlock system, it is important to realize that they are in every way equipped to provide enterprise-level storage. These enterprise storage features include the ability to use virtual provisioning or thin provisioning, supporting over-provisioning and delivering storage capacity in a just-in-time fashion. File deduplication is used for file-level storage to reduce the need for physical capacity. When multiple files have the same data, using deduplication stores just one copy of the data and shares it between the multiple applications and users. Instead of storing multiple copies of the data, just a single copy is stored. Compression is a method of altering the way data is stored to improve storage efficiency. Compression is efficient in capacity reduction, but it does impact a storage array's CPU usage during the compression. Compression affects the disk read performance depending on the efficiency of the decompression and isn't recommended for all situations.
Let's switch gears and turn our attention to the compute side of the VBlock System 100. Specifically, we'll talk about the compute components and the configurations available in each of the VBlock System 100 models.
You learned a few moments ago that the 3 in the Model BX standard configurations indicate that they come with 3 servers. The naming works the same way for the Model DX, which offers standard configurations with 6 and 8 servers. The Cisco C-Series rack-mount server used in the VBlock System 100 compute is a high-density 2-CPU socket, 1-rack unit server. They are built for production-level network infrastructure and mainstream data center branch and remote office applications. They offer flexible memory configurations of either 48 GB for the BX model and 96 GB for the DX model. But remember, the standard amount of memory can change at any time as the product evolves. Check the latest documentation for the current options. VCE pre-installs VMware ESXi on these servers. Bare metal servers do not come with ESXi pre-installed, but VCE requires customers to follow its bare metal standards. Bare metal is not available on VBlock Series 100 model BX. Cisco C-Series rack-mount servers can be added to VBlock System 100 Model DX. The minimum number of servers in a VBlock System 100 is 3, and 8 servers is the maximum. The servers are added one at a time. Bare metal can be added to a VBlock 100 Model DX, but the most current VCE bare metal guidelines must be adhered to. VBlock 100 Model DX and Model BX come with a number of ESXi host licenses. These hypervisors are deployed in cluster configurations. VMware vSphere is the virtualization platform that provides the foundation for private cloud. It allows hypervisors to be deployed in a cluster configuration, allowing customers to combine multiple ESXi hosts into a group that pools all of their CPU and memory resources. Having compute resources in a pool provides greater flexibility while allocating resources to virtual machines. This creates significant flexible workload mobility. Because clustered ESXi hosts share the same LUN, it is easy to move a virtual machine from one physical ESXi host to another while the virtual machine is running. Imagine how useful it is to be able to move a virtual machine from a host experiencing performance issues to a different physical server without interrupting the running virtual machine.
You've learned about the VBlock System 100 storage and compute. Now let's spend a moment discussing the network switch, which is unique to this VBlock System platform.
The Cisco Catalyst network switch is a multi-layer gigabit Ethernet network switch. This switch provides all VBlock System 100 network connectivity over Ethernet. The VBlock System 100 is the only VBlock system that does not offer fiber channel-based SAN. Block-level storage is provided without fiber channel using the iSCSI protocol over Ethernet for all block-level storage needs, including booting system servers. This switch also handles all typical LAN traffic, including file-level storage access. This is a stackable enterprise-class switch that provides industry-leading security, best availability for a switch of its kind, highest quality of service, and the lowest cost of operation.
Before we finish the overview of the VBlock System 100, there's one more topic. Let's spend a couple of minutes talking about system management.
The VBlock System 100 utilizes a logical amp, or LAMP. Remember that the AMP is a server that includes many of the management tools required to configure, manage, and operate a VBlock system. Unlike the physical AMP in some other VBlock system models, the AMP on the VBlock System 100 is logical and resides on hosts in the VBlock. The management tools run on the LAMP are listed on this page. At this point in your training, you don't need to understand the tasks that each of these tools is responsible for, but understand that they run on the LAMP. The LAMP comes ready to run all of these tools, which are pre-installed at the factory and optimally configured to do so.
Organizations constantly evaluate the security of data center operations, and most place specific emphasis on externally facing IT infrastructure. The issue with external-facing IT infrastructure is exposure to potential security threats from hackers attempting to access internal networks, intellectual property, and customer data. Once an internal device like a network switch, storage drive, or server, is compromised, an intruder can explore and find other internal network devices and cause disruptions of IT resources or even the theft of data. Organizations in every industry worry about security threats to external-facing IT infrastructure. The business models and strategies of many companies requires interfacing with customers, partners, and others over the Internet. The ability to safely conduct business over the Internet is critical in most industries. These organizations use the Internet for retail and wholesale selling, collaborating with partners, educating students, providing services, direct marketing, public relations, technical support, and many other important services. Doing business over the Internet presents a compromise where companies can more easily conduct business but have far less control over the Internet where managing security is more challenging. Here, external threats to ongoing operations and data theft are real vulnerabilities, with potentially severe consequences such as the interruption of operations and the real possibility of compromised data, including customer data and intellectual property. These organizations strive to achieve and maintain balance between the strategic need to do business over the Internet and the need to protect internal networks and data. To manage these risks, some companies choose an IT demilitarized zone, or IT DMZ, as part of their protection strategy. Borrowing a concept and phrase from military strategy, some companies today create a demilitarized zone, or DMZ, between their internal IT infrastructure and external threats. In the military sense, a DMZ is an area that no one owns between the borders of military foes. The DMZ serves as a buffer zone designed to preserve peace and property. Similarly, an IT DMZ is an area between a company's internal IT infrastructure and the Internet. In this case, on the borders of the DMZ are two firewalls. The first rests between the open Internet and the DMZ. Here, a company can impose some security that allows it to protect IT devices within the DMZ, while they provide access to the Internet to satisfy business strategies. The second firewall straddles the border that divides the DMZ from internal-facing networks and data. Internal-facing resources are protected with the highest levels of security to secure ongoing operations and sensitive data. Only hardware and software deployed in the DMZ is exposed to lower levels of security and interact directly with the Internet. Hardware and software deployed in a DMZ is exposed to lower levels of security and interact directly with the Internet. Now let's try to apply this concept. Given what you've already learned about the IT DMZ strategy, what data or functions listed here should reside on internal-facing IT infrastructure, where the greatest level of security is possible? There are lots of different methods and strategies to approach these decisions, but most would agree that strategic IP and sensitive customer data are both critically important and should be highly protected. Depending upon organizational priorities, other items listed here could reside within an IT DMZ. Now that you have an understanding of the purpose of an IT DMZ, let's talk about how a VBlock System 100 can be applied. Companies using a DMZ strategy must build an IT infrastructure that will function on its own in isolation from other internal-facing IT equipment. That means that compute, network, and storage capabilities must be built into the DMZ area. Remember that the vBlock System 100 provides compute, network, and storage in a single enclosure. It, in effect, provides a complete IT infrastructure that can easily be installed as a DMZ in a box, separate from other IT infrastructure. Some of the benefits of using the vBlock System 100 as a DMZ infrastructure are listed here. It's easy to purchase and install with minimal testing and architecting required. It is also easily isolated from other IT infrastructure that must be protected from the threats presented by the Internet and other external networks. And for organizations that have already deployed vBlock systems, the tools, procedures, and skills already used in the data center can be utilized to deploy and maintain the infrastructure in the DMZ. This is a learning check that provides an opportunity for you to assess your progress. Each question provides feedback to help you remember the content, and a score is provided at the end so you can assess how you are doing. This is not a test and is not part of the certification assessment. Learning check scores are not retained in your records. However, completing these learning checks is great preparation for the certification assessment that comes later. You may take this learning check as many times as you want. Click Next to get started.
Congratulations! You've completed the introduction to the vBlock System 320 and the vBlock System 340. In this section, you learned about the vBlock System 320 and vBlock System 340 capabilities relative to the other vBlock system platforms. You also learned about their typical use cases, as well as their standard configurations. You learned about the vBlock System 320 and the vBlock System 340 basic compute, storage, networking, and virtualization technologies. And finally, you learned about the vBlock System 320 and the vBlock System 340 management technologies. There is one last platform to learn about in this training, so let's move on to the introduction to the vBlock System 720. Welcome to the next section of the vBlock Foundations training. In this section, you'll learn about the details of the vBlock System 720, which is the last of the 4 vBlock system platforms discussed in this course. Upon completion of this training, you'll be able to describe the vBlock System 720 relative to the other vBlock system platforms and identify the typical use cases for this system. You will also be able to identify and compare the vBlock System 720 configurations and identify the basic components that comprise the compute, storage, networking, and virtualization technologies. You'll be able to describe the differences between the segregated network and the unified network configurations of the vBlock System 720. Finally, you'll be able to explain the purpose of the components of the vBlock System 720 management technology.
The vBlock System 720 is the highest capacity vBlock system offering. It is similar in many ways to the capabilities of the vBlock System 320 and vBlock System 340, except, as you will learn in this section, it offers dramatically greater capacity. The vBlock System 720 components are similar to the vBlock System 320 and vBlock System 340, with the most significant difference being in the system storage. For networking, the vBlock System 720 offers both segregated and unified networking, and the vBlock System 720 uses the same UCS compute components. However, the vBlock System 720 uses only the EMC vMax storage products that you have learned about earlier in the storage section. You will learn here that there are 3 different EMC vMax products utilized for the storage in vBlock System 720 models. The vBlock System 720 is engineered for the most demanding IT environments. It is an enterprise or service level provider class mission critical system that supports enterprise workloads and service level agreements that run thousands of virtual machines and virtual desktops. Architecturally designed to be modular, providing flexibility and choice of configurations customizable to suit customers' demanding core data center services and workloads. These include business-critical enterprise resource planning or ERP installations, SAP solutions, customer relationship management CRM applications, demanding databases, messaging, collaboration services, and other mission-critical IT needs. vBlock System 720 delivers a multi-controller, scale-out architecture with consolidation and efficiency for the enterprise. It allows scaling of resources through common and fully redundant building blocks. vBlock System 720 is designed for deployments involving large numbers of virtual machines and users. vBlock System 720 is a modular platform with defined scale points that meet the high performance and availability requirements of an enterprise's business-critical applications. Its features include enterprise-scale performance and data availability. The new vBlock System 720 offers blade servers that are more dense, which means that each server has greater compute power packed into the standard blade. It has an Ethernet-ready unified network topology and a choice of storage arrays. All of this leveraging the latest virtualization platform, providing twice the performance and scale of the previous release. The vBlock System 720 offers extraordinary flexibility. It provides greater configuration choices to meet a broad spectrum of business needs, including consolidation of applications and infrastructure. Organizations managing the most demanding business-critical workloads don't all have the same demands. vBlock System 720 configurations allow these customers to purchase capacity customized to their IT needs. In terms of data protection and mobility, vBlock Systems 720 offer backup and recovery, data replication, business continuity, and workload mobility, all designed to deliver reliable and predictable data protection for vBlock systems. Security and compliance in the vBlock System 720 is engineered, architected, and hardened according to the best practices of each component, including EMC's storage, Cisco's compute and networking, and VMware's virtualization. Systems management. VCE delivers intelligent systems management of vBlock System 720, optimizing services and integrating directly into VMware technologies. VCE also provides an extensible API to leading management tools to protect investments in existing management frameworks. Greater agility. Because the vBlock System 720 is pre-integrated, pre-tested, and validated in the factory, vBlock System can be ordered and delivered within 45 days. Deployment is typically within a week, which includes knowledge transfer. Reducing business risk. vBlock systems are deployed by our 150 vBlock-ready global qualified partners, giving customers a choice of certified professionals that use standardized, proven services. This enables faster time to production for projects and follow-on activities. Streamlined support experience. Like all other vBlock systems, once deployed, VCE support dramatically simplifies the support process, proactively identifying and resolving issues to improve time to resolution and deliver a better support experience. The vBlock System 720 is capable of greater capacity than other vBlock systems. It is designed and engineered to achieve the scale needed for virtual environments that require the most demanding workload and service levels. It is intended for a wide range of mission-critical applications in rapidly growing enterprises. These include core data center services, mixed workloads such as virtual desktop infrastructure VDI implementations, SAP, Oracle, and Microsoft Exchange. Demanding enterprise resource planning, ERP applications, cloud services, demanding database, business continuity, or disaster recovery services, as well as application development and testing. Like all VBlock systems, the VBlock System 720 models are pre-configured hardware and software platforms. Despite their size and the number of cabinets they can occupy, the VBlock System 720 models are engineered and validated to operate as a single unit. As you can see from the number of cabinets that can constitute a VBlock System 720, physically they can consume more floor space than other VBlock systems. However, realize that this is significantly less space than non-VBlock systems with similar capacity. These systems can contain as many as 48 Cisco UCS chassis filled with Cisco UCS B-Series blade servers, which provide substantially greater compute capacity. Like other VBlock systems, there are 2 IP switches and 2 SAN switches. But the VBlock System 720 offers several alternative switches that can provide greater network capacity. As you already learned, these systems utilize the EMC VMAX storage products, including the VMAX 10K, VMAX 20K, and VMAX 40K, with distinct storage capacities as listed here. The VBlock System 720 comes with the VMware vSphere hypervisor and has a physical amp, which we'll provide more details on later. Let's take a few minutes to address the connectivity within the VBlock System 720. You'll see that there are some similarities with other VBlock systems, but also important differences to understand. We'll start with a look at systems architected with unified networking and block-level storage. Like the VBlock System 320 and VBlock System 340, Cisco B-Series blade servers with blade server chassis and fabric interconnects are used in the VBlock System 720. However, a VBlock System 720 can have up to 5 UCS domains, which means that it can contain many more chassis and pairs of fabric interconnects than is found on other VBlock systems. You'll learn more about Cisco UCS domains and how VBlock System 720 models achieve great capacity in a couple of minutes. For networking switches, the unified configuration uses a Cisco Nexus switch for both LAN and SAN networking, and it offers a higher capacity switch than those offered in other VBlock systems. This higher capacity switch can provide greater network throughput and accommodate both the higher capacity compute and storage found in the VBlock System 720 models. Unlike other VBlock system models, with the EMC VMAX storage, VBlock System 720s can have more than 2 storage processors. The VBlock System 720 with VMAX 10K can have up to 4 storage processors, while the VBlock System 720 with VMAX 20K and VMAX 40K can have as many as 8 storage processors. In VMAX, the storage processors are referred to as engines. These systems can also have many disk array enclosures, or DAEs. Note that every unified network switch has 2 connections to every storage processor, and every storage processor is connected to all DAEs. In the VBlock System 720 models with unified network and unified storage, data movers are added to the configuration to perform file server tasks. On the network side, each data mover is attached to the LAN or Ethernet ports on both Cisco Nexus unified switches. And on the storage side, each data mover is connected to every storage processor. To switch from unified network to a segregated network, the 2 unified network switches are replaced with a pair of Cisco Nexus LAN switches and a pair of Cisco MDS SAN switches. The combination of these 4 switches provides more network ports for greater network capacity than is possible with just the 2 unified switches. And finally, the last configuration we'll discuss here is segregated network with block-level storage. As you learned earlier, while file-level storage requires file servers or X-blades, block-level storage does not. Note that for the segregated network, the LAN and SAN switches remain, and block-level storage is configured with no data movers.
You've learned about the basics of the VBlock System 720, so now let's discuss details about its components. We'll start with the compute technology.
We mentioned a moment ago that VBlock System 720 models can contain multiple UCS domains. We haven't talked about domains when discussing other VBlock System models. But think back to the VBlock System 320 and VBlock System 340. Here's what the compute looks like in those systems. There is a pair of fabric interconnects and multiple blade server chassis containing blade servers. This is a single UCS domain. Every UCS domain consists of a pair of fabric interconnects and multiple chassis and blades. For VBlock System 320 and VBlock System 340, they contain one and only one UCS domain and cannot contain multiple domains. Imagine a VBlock system with two domains, essentially a single VBlock system with the equivalent compute power of two separate VBlock System 320s or VBlock System 340s. Basically, this is what customers can purchase on a single VBlock System 720. Customers can purchase a VBlock System 720 with one domain, or they can purchase a VBlock System 720 with two domains like you see here. And if the purchaser needs more compute capacity, they can add a third UCS domain, or a fourth domain. Actually, a customer can purchase a VBlock System 720 with up to 5 UCS domains. Or they can add up to a total of 5 domains after purchasing a VBlock System 720. That provides a tremendous amount of compute capacity in a single VBlock system. So now you can see, relative to other VBlock systems, just how much capacity a single VBlock System 720 can provide. Just like the VBlock System 320 and VBlock System 340, the VBlock System 720 uses the Cisco B-Series blade servers. Any B-Series blade server offered by VCE can be purchased with these systems. Depending on the blade model, they can contain 2 or 4 multi-core processors, and there are many different RAM configurations available. Blade servers are inserted into slots in the blade server chassis, and these chassis can hold 8 half-width blades, 4 full-width blades, or a combination of the two. 2 fabric extenders in each chassis provides the connectivity between the blade servers and the fabric interconnects. Each chassis has redundant power and cooling components to achieve high availability. Fabric interconnects provide connectivity from each UCS domain in the system compute to the networking and storage components. Fabric interconnects are configured in pairs for high availability, and each pair of fabric interconnects define the boundaries of a single UCS domain. Bare metal rules of other VBlock systems are also applied to the VBlock System 720.
Now let's move on from the compute components to discuss the VBlock System 720 storage technology. As you have already learned, this system uses the EMC VMAX storage products. These will be the focus of this section.
The EMC Symmetrix VMAX family offers high-end storage systems built for the virtualized data center, with consistent and predictable performance and consolidated workloads. The EMC Symmetrix VMAX family can provide several petabytes of storage, utilizing tens to thousands of physical storage drives, and as you learned earlier, can contain from 2 to 8 storage processors. Within VBlock systems, they connect to the compute via fiber channel SAN. EMC VMAX products provide tiered storage using enterprise flash drives, fiber channel, and SATA storage drives. And for customers that require file-level storage, a NAS gateway that serves as the file server is optional. There are 3 different EMC VMAX products utilized in the VBlock System 720 models: the VMAX 10K, VMAX 20K, and VMAX 40K. From the details in this table, you can see the maximum drives and the I/O ports vary depending on the EMC VMAX model. Notice that the drive type options are the same across all EMC VMAX models, And the available RAID configurations include RAID 1+0 for best performance, RAID 5 for the best mix of performance, protection, and economy, and RAID 6 for increased protection with read performance. To accommodate block-level storage, the vBlock System 720 can contain up to 8 engines. System memory of each engine varies depending on the vMax model, and the Fibre Channel protocol is used for block-level storage across all vBlock System 720 models. For file-level storage, the number and type of processors contained in each X-blade and the amount of memory vary, as you can see in this table. And the protocols that support file-level storage are the same across all vMax models.
The last hardware components that we will talk about are the vBlock System 720 network technologies. Here we'll discuss the network switches available in this system.
The Cisco Nexus network switch is available in the vBlock System 720. As in other vBlock system models, this switch serves as a LAN switch in systems with segregated networks and as a unified switch capable of supporting both Ethernet and Fibre Channel in a unified network. These switches can accommodate both Fibre Channel ports supporting the vBlock system's SAN as well as Ethernet ports for LAN network traffic. For the vBlock System 720, a higher capacity Cisco network switch is available that is not utilized in other vBlock system models. This higher capacity switch can provide greater network throughput to accommodate both the higher capacity compute and storage found in the vBlock System 720 models. The Cisco MDS SAN switch is only included in systems with segregated networking. This switch only carries network traffic dedicated to the SAN and has only Fibre Channel ports. It supports connectivity for backup, business continuity using EMC recover point and storage federation requirements. The MDS switches provide line rate ports for non-blocking 8 gigabits per second throughput, and higher capacity switches are available in the vBlock System 720 that is not an option for other vBlock system models. Like other vBlock system models, the vBlock System 720 also comes with the Nexus 1000V virtual network switch. While customers can choose to use other virtual switches, the Nexus 1000V is the only virtual switch that is included in the VCE core support. This virtual switch is used to provide connectivity from virtual machines created and running on the vBlock system to the physical network. Virtual Supervisor Module, or VSM, is the control software on the Cisco Nexus 1000V virtual switch. It runs on a virtual machine and is based on Cisco NXOS software. Virtual Ethernet Module, or VEM, is part of the Cisco Nexus 1000V that actually switches data traffic. The switch is the standard virtual switch in the vBlock systems, replacing the switch that comes with vSphere.
There are just 2 topics left. You'll learn about the vBlock System 720 virtualization now. Then we'll finish this section of the training with a discussion about system management.
The vBlock System 720 comes with a number of ESXi host licenses. These hypervisors are deployed in cluster configurations. VMware vSphere is the virtualization platform that provides the foundation for the private cloud. These hypervisors are usually deployed in a cluster configuration to enable pooling of resources. As you learned earlier, ESXi hosts in a cluster share LUNs. This simplifies management tasks and makes it easy to move a virtual machine from one physical server to another while the virtual machine is running. VMware vCenter Server comes installed on the vBlock System 720 and provides functionality for cloning or copying virtual machines, as well as for creating templates that can be used to create duplicate virtual machines. It includes both VMware vMotion and VMware Storage vMotion. Click the links if you want to learn more about these. vBlock systems come configured with DRS and VMware vSphere HA clusters. VMware Update Manager provides information and tasks for vCenter upgrades and patch management. The SQL Server is the database backend for vCenter. It runs on a separate virtual machine from the vCenter for performance and portability.
Let's turn our attention to the last topic, VBlock System 720 Management. We'll talk about both the AMP and the management software tools used in the VBlock System 720.
All VBlock 720 models require a Physical Advanced Management Pod, AMP. As you learned earlier, these are used to manage the VBlock system with dedicated hardware that separates management traffic from user workload traffic. The two configurations that you learned about, the mini-AMP and the HA-AMP, are both available on the VBlock System 720. Remember, as we discussed earlier, in the near future, the two AMP configurations will be replaced by a new VBlock system management infrastructure, providing a broader range of options with greater flexibility in customization to the customer's needs. The servers of the AMP are configured with internal storage. The HA-AMP also includes VNXE 3150 for shared storage for backup purposes. As we discussed earlier, a key differentiator to the VCE VBlock system over other cloud appliances and the traditional data center model is the Strategic Advanced Management Pod, AMP. The VBlock System 720 has a physical AMP. The management software that is installed on the VBlock System 720 AMP is listed here. Take a moment to review this list and click on any of these links for more information.
This is a learning check that provides an opportunity for you to assess your progress. Each question...
Well done! You've completed the Introduction to the VBlock System 720. In this section, you learned about some of the details of the system, including how it compares to other VBlock system platforms, its use cases, and about the VBlock System 720 configurations. You also learned about its compute, storage, network, and virtualization technologies. And finally, you learned about the differences between the segregated and unified network configurations and about the VBlock System 720 management technology. Congratulations! You've completed the Introduction to the VBlock System 100. In this section, you learned about the VBlock System 100 relative to the other VBlock system platforms, the typical use cases for the VBlock System 100, and the two VBlock System 100 models. You also learned about the VBlock System 100 general purpose and performance configurations, and about the basic components that constitute the compute, storage, networking, and virtualization layers of the platform. You're ready to move on now to the next section, which addresses the VBlock System 200. This is the first of several modules presenting foundations training on the VBlock system technology. In this section of the Foundations training, you'll learn more about the VBlock System 200 platform. This system has similarities, but also important differences with the VBlock System 100 that you just learned about. Upon completion of this training, you'll be able to describe the VBlock System 200 relative to the other VBlock system platforms. You'll also be able to identify the typical use cases for the VBlock System 200 and identify the VBlock System 200 basic components that constitute the compute, storage, networking, and virtualization technologies. Let's get started by discussing how the VBlock System 200 compares to the other VBlock system platforms.
The VBlock System 200 is a step up from the VBlock System 100 in terms of size and capacity. Like the VBlock System 100, it targets IT needs that don't require the power and capacity of larger VBlock systems. Like all VBlock systems, it provides a simplified, standardized infrastructure and operational process with predictable performance and operational characteristics right-sized to meet customers' space and workload requirements. There are two primary differences between the VBlock System 100 and the VBlock System 200, and they involve storage and networking. First, the storage array in the VBlock System 200 is the EMC VNX, not the VNXE found in the VBlock System 100. The VNX can support higher input-output operations than the lower-cost VNXE, which means the VNX can handle more input and output operations in a period of time. On the network side, unlike the VBlock System 100, the VBlock System 200 has a SAN network. This system uses a Cisco Nexus network switch as a unified switch with both fiber channel and Ethernet capabilities. You'll learn more about these details shortly. VBlock System 200 is another value-focused solution for mid-sized data centers and enterprise distributed locations. It is capable of delivering core IT services in most data centers, and it can efficiently handle most mixed workload requirements. As mentioned, it is specifically priced and built for today's enterprise-level mid-size IT deployments. It is easy for customers to purchase and deploy as it is pre-configured and validated. It can be up and running in as little as 30 to 45 days after order. Like the VBlock System 100, the VBlock System 200 is designed for and targets mid-sized data centers and enterprise distributed locations. It has enough power and capacity to handle most mixed virtualized and non-virtualized workloads. It can serve as a platform for virtualized infrastructure dedicated to optimizing the management and performance of a single workload. It can be used as a disaster recovery appliance that can run critical workloads when a production system becomes unavailable due to a disaster. The VBlock System 200 can do this with a tool like vCenter Site Recovery Manager, which provides automated rules, coordination, and management of the disaster recovery process. The VBlock System 200 can also be used as an application development and test system, isolated from production systems, but easily able to migrate applications from development to production when ready.
Physically, the V-Block System 200 is packaged in a 42 RU tall cabinet, which measures about 80 inches high. The cabinet is a standard 28 inches wide and 42 inches deep. The weight and power requirements of the V-Block System 200 both depend on the configuration. The V-Block System 200 uses the same Cisco C-Series servers as the V-Block System 100. However, V-Block System 200 can have from 4 to 12 of these servers, and memory ranges from 64 gigabytes per server up to 256 gigabytes per server. The V-Block System 200 has two Cisco Nexus switches that are unified switches with both Fiber Channel SAN and Ethernet LAN ports. The V-Block System 200 has a separate management network switch. The management network switch carries only management traffic to and from the LAMP. This separates user workload traffic from system management traffic. This is useful when tenants of the V-Block System 200 want or need their traffic isolated from management traffic. As you have already learned, the storage array is an EMC VNX. The V-Block System 200 also comes pre-installed with vSphere Enterprise Plus and VCE Vision Intelligent Operation. The V-Block System 200 is contained in a single full-height cabinet. Like the V-Block System 100, the compute in the V-Block System 200 consists of Cisco C-Series rack mount servers. But instead of connecting to a Cisco Catalyst network switch, the V-Block System 200 utilizes Cisco Nexus switches. This is a unified switch providing both SAN and LAN network connectivity. Block-level storage is provided through SAN connectivity to the storage processors in the disk processor enclosure, or DPE, using the Fiber Channel Protocol. Compute servers boot from files stored in block-level storage. The unified switch also supports the V-Block 200 LAN. File-level storage is available with the addition of data movers, which connect using Ethernet ports in a unified network switch. Site network connectivity is also provided through the LAN connectivity. A single DPE is included in all V-Block System 200s. DAEs can be ordered as part of the V-Block System 200 initial purchase or can be added after deployment.
That was a good overview covering the basics of the V-Block System 200 and its connectivity. Now let's discuss the individual components in more detail, starting with the system compute.
The Cisco C-Series rack mount server used for the V-Block System 200 compute is a high-density 2 CPU socket, 1 rack unit server. They are built for production-level network infrastructure and mainstream data center, branch, and remote office applications. Customers have several CPU options depending on the processing power required and the needs to manage power consumption, as well as other criteria and needs. They offer flexible memory configurations, currently up to 256 gigabytes, which may change over time as the product evolves. VCE pre-installs VMware ESXi on these servers. V-Block System 200 system servers can be deployed without hypervisors. These can run non-virtualized applications and are referred to as bare metal servers because they are delivered with no software pre-installed. Bare metal workloads cannot use the same physical storage drives as virtual workloads because they create different demands on physical drives and can't be managed with virtual infrastructure management tools. Sharing storage drives with bare metal workloads can disrupt the workload balancing capabilities that provides significant benefits when virtualizing storage. Bare metal deployment must comply with VCE bare metal guidelines. V-Block System contains only VCE published, tested, and validated hardware and software components. Operating systems used on bare metal deployments for compute and storage components must comply with Cisco and EMC hardware and software compatibility guides. VCE supports only VMware hypervisors and does not provide support for other hypervisors.
Now that you understand more about the system compute components, let's turn our attention to the V-Block System 200 storage components.
While there are several VNX models, only one is used in all V-Block System 200. At the time this training is being developed, it is the VNX 5300, which could change in the future. V-Block System 200 models include cabinet space, cabling, and power to support the hardware for both block and unified storage. Both EMC fully automated storage tiering and fully automated storage tiering cache are available to customers. Click these links for more information about these products. This VNX model provides centralized management, is optimized for virtual applications, and supports a broad selection of storage drives. The base storage configuration of the vBlock System 200 provides block-level storage capabilities. The VNX supports SAS, nearline SAS, and enterprise flash drives. It has 6 I/O slots and 2 storage processors, which at the time this training was published had 8 gigabytes of memory per storage processor. This base configuration supports a SAN using Fibre Channel. For unified storage, additional hardware in the form of 2 data movers is added. These provide the file server capability needed to implement file-level storage. Each data mover has 6 gigabytes of memory. File-level storage utilizes the NFS or CIFS protocols and is accessed over the vBlock system LAN. In the vBlock system base configuration, there is a 25-drive disk processor enclosure, or DPE. Recall that a DPE houses both storage drives and storage processors. 8 of the drives are designated as vault, where data in cache is saved when there is a power interruption. The FAST suite of software, including FAST and FAST Cache, is also part of the base configuration. There are no DAEs as part of the base configuration, but can be purchased as part of the vBlock System 200 purchase or added at a later date. Up to 2 15-drive DAEs can be added for the nearline SAS drives, as well as 2 25-drive DAEs for EFD and or SAS drives. Drives are added in RAID packs, and more information about these can be found in the appropriate VCE Release Certification Matrix or in the Advanced Configuration tool called ACT. For unified storage, 2 data movers are added to provide file-level storage. In general, any option available at the time of purchase can be added as an upgrade at a later time.
So far, we've covered the vBlock system compute and storage components, and there are only a couple more topics to address. In this section, we'll briefly review the network switch found in the vBlock System 200.
The 2 unified network switches in the vBlock System 200 are Cisco Nexus switches. These switches provide all of the network connectivity related to user network traffic and have both Fibre Channel ports to support the SAN and Ethernet ports to support the LAN. Remember that block-level storage is accessed through the SAN. File-level storage and the customer's site network are accessed through the LAN. As discussed earlier, the vBlock System 200 has a separate management network switch. The vBlock System 200 management switch is a Cisco Catalyst switch that carries only management traffic to and from the LAMP. By utilizing this management switch, customers can separate user workload traffic from system management traffic. This is useful when there are multiple tenants using the vBlock System 200 who want or need their network traffic isolated.
So far, you've learned about the hardware components that are part of the vBlock System 200's compute, storage, and networking layers. It's time to talk now about the virtualization and management. We'll start with virtualization.
Like the vBlock System 100, the vBlock System 200 comes with a number of ESXi host licenses. These hypervisors are deployed in cluster configurations. VMware vSphere is the virtualization platform that provides the foundation for the private cloud. Hypervisors are deployed in a cluster configuration to pool resources. As you learned earlier, ESXi hosts in a cluster share LUNs. This simplifies management tasks and makes it easy to move a virtual machine from one physical server to another while the virtual machine is running. VMware vCenter Server comes installed on the vBlock System 200. It provides functionality for cloning virtual machines and creating templates that can be used to generate duplicate virtual machines. It includes both VMware vMotion and VMware Storage vMotion. Click on the links if you want to learn more about these products. vBlock System 200 comes configured with DRS and VMware vSphere 8J clusters. VMware Update Manager provides information and tasks for vCenter upgrades and patch management. SQL Server is the database backend for vCenter. It runs on a separate virtual machine from vCenter for performance and portability.
You're just about done. This last section of the training addresses vBlock System 200 management.
A key differentiator to the VCE vBlock system over other cloud appliance is the Strategic Advanced Management Pod, or AMP. In the vBlock System 200, it is called a Logical Advanced Management Pod, or LAMP. This is an ESXi cluster dedicated to managing the vBlock System 200. Unlike larger vBlock systems with physical AMPs, the vBlock System 200 management has no dedicated hardware. The management software that runs on the LAMP is listed here. Take a moment to review this list. Click on any of these links for more information.
This is a learning check that provides an opportunity for you to assess your progress. Each question provides feedback to help you remember the content, and a score is provided at the end so you can assess.
Introduction to the vBlock System 200. In this section, you learned about the vBlock System 200 relative to the other vBlock system platforms. You also learned about the vBlock system use cases and the basic components that constitute the vBlock system compute, storage, networking, virtualization, and management technologies. So far in this training, you've learned about the vBlock System 100 and the vBlock System 200. We're ready now to move on and learn about the vBlock System 320 and vBlock System 340. So far in this training, you've learned about the mid-range vBlock systems, including the vBlock System 100 and the vBlock System 200. In this section, you'll begin to learn about the higher capacity vBlock systems, starting with the vBlock System 320 and the vBlock System 340. The vBlock System 320 has been available representing the vBlock System 300 family for some time. It will continue to be sold, but at the same time, the vBlock System 340 is being introduced. We'll spend time discussing both of these models. Upon completion of this section, you'll be able to describe the vBlock System 320 and the vBlock System 340 relative to the other vBlock system platforms. You'll be able to identify the typical use cases for the vBlock System 320 and vBlock System 340, as well as identify and compare the vBlock System 320 and vBlock System 340 standard configurations. You'll be able to identify the vBlock System 320 and vBlock System 340 basic compute, storage, network, and virtualization technologies. And finally, identify and explain the purpose of the components of the vBlock System 320 and the vBlock System 340 management technology.
The vBlock System 320 and vBlock System 340 models represent a step up from the smaller vBlock System 100 and vBlock System 200. Beginning with the vBlock System 300 family and extending to the vBlock System 700 family, these are much higher capacity systems, designed and customizable to satisfy nearly any large enterprise IT needs. Like all vBlock systems, they provide a simplified, standardized infrastructure and operational process with predictable performance and operational characteristics right-sized to meet a customer's space and workload requirements. This table illustrates the differences between the models we've discussed in detail to this point in the training. Unlike the vBlock System 100, which utilizes EMC VNXE storage, the rest of the systems here utilize EMC VNX. Beyond storage, there are significant differences in networking and compute. The vBlock System 320 and vBlock System 340 are the first systems we've discussed in detail that offer segregated networks utilizing both SAN and LAN switches, in addition to the unified networking alternative. Also, for the first time, you will learn about vBlock system models utilizing B-Series blade servers instead of the C-Series rack mount servers. As you've learned earlier in the compute section, these blade servers come as part of a compute system that includes blade server chassis and fabric interconnects. Now, let's take a look at the details of these systems.
The VBlock System 320 and VBlock System 340 are designed to run a wide range of mission-critical applications in rapidly growing enterprises. Able to support large enterprise deployments, these systems are engineered for performance and significant scalability. At the same time, the VBlock System 320 and VBlock System 340 provide greater configuration choices in terms of storage, high availability configurations, and converged networking. In addition, these systems feature a spectrum of the market-leading EMC VNX models, including the latest in storage technology. Like all VBlock systems, the VBlock System 320 and VBlock System 340 are optimized designs that provide fast delivery times and high performance. These systems are engineered considering most of the common workloads encountered by organizations. These systems offer block-level storage configurations as well as unified storage configurations with both block-level and file-level storage capabilities. For networking, VBlock System 320 and VBlock System 340 models can be purchased with segregated networking, utilizing separate network switches for SAN and LAN to most cost-efficiently address high port count environments. For lower port counts, a unified switch provides a less costly networking alternative by supporting both fiber channel and Ethernet ports in the same device. These systems offer base configurations with fewer drives, fewer blades, and optimized compute and storage for specific workloads. It is usually advisable to add both compute and storage simultaneously to maintain the designed efficiencies of the VBlock system. For system management, advanced management pod models are available to satisfy either lower cost or high availability system requirements. There are power connectivity options available to meet regional and data-specific needs of each system. Power configuration is one of the many considerations that are taken care of when designing a VBlock system to be sure that it can be put quickly into production after arriving at the customer location. And finally, a feature that may go unnoticed by some is the internal patching between cabinets. The system provides a high degree of consistency and physical connectivity of system components throughout all VBlock cabinets, providing common labeling and routing, which eliminates many of the cable management nightmares encountered in traditional data centers. The VBlock System 320 and VBlock System 340 models are designed and engineered to achieve the scale needed for virtualized data center environments. These systems are capable of running a wide range of mission-critical applications in enterprises, particularly those that are growing rapidly. These include core data center services, mixed workloads such as SAP, Oracle, and Microsoft Exchange, demanding enterprise resource planning applications, cloud services, virtual desktop infrastructure implementations, demanding databases, business continuity or disaster recovery services, as well as application development and testing. Physically, the VBlock System 320 and VBlock System 340 models can vary greatly in size, weight, and capacity. But in terms of the cabinets used to house and connect their components, the cabinets are all 42 RU tall, which is about 84 inches. They are 28 inches wide and 48 inches deep. The weight and power requirements of each loaded cabinet vary significantly, as these are flexible systems that may be customized in many ways. Although they are flexible, they are highly consistent in component locations and cabinets, which provides significant predictability for system deployment, servicing, and performance. And the power distribution units used to connect a site power supply are capable of connecting in a variety of ways to meet the needs of any data center. The VBlock System 300 family is designed to be agile and efficient, addressing a broad spectrum of workloads. To this end, the VBlock System 320 and VBlock System 340 systems are sized for many needs. This page lists each of the VBlock System 320 and VBlock System 340 models, and notice that the primary difference between them is the VNX model used. VBlock System 320 uses older VNX models, while the VBlock System 340 incorporates the new models. We'll talk about the general differences of these models later. Despite the differences, from the smallest one-cabinet system containing VNX 5300 through the largest 8-plus cabinet system equipped with VNX 7600 and VNX 8000, system characteristics are determined by the intended workload. It's all about purchasing the IT capability required to meet a customer's specific needs. This table lists each of the VBlock System 320 and VBlock System 340 models. You can see that the primary difference is the VNX models used. Note that the VBlock System 320 uses older VNX models, while the VBlock System 340 incorporates the newer models. All of the VBlock System 320 and VBlock System 340 models use the Cisco UCS B-Series blade servers, and each can contain multiple chassis and many individual servers. Note, the number of chassis and blades each system can hold is subject to change at any time, and the latest release compatibility matrix is the definitive source for various system limits. Systems with segregated networks will contain both Cisco Nexus LAN switches and Cisco MDS SAN switches. In systems with unified networks, the Cisco Nexus switch will include both SAN and LAN ports and provide both Ethernet and fiber channel network connectivity. Like all VBlock systems, these come with Nexus 1000V virtual switches that provide connectivity between virtual machines running on the VBlock system and the physical network. The number of cabinets needed to house each model varies as shown in this table. Let's take a few minutes to address the connectivity within the VBlock System 320 and VBlock System 340. We'll start with a look at systems architected with unified networking and block-level storage. Unlike the Cisco C-Series rack-mount servers in the VBlock System 100 and VBlock System 200, the VBlock System 320 and VBlock System 340 use Cisco B-Series blade servers secured in Cisco UCS blade server chassis. In addition, the VBlock System 320 and VBlock System 340 compute include a pair of Cisco fabric interconnects, which provides connectivity from compute to the system network and storage components. The UCS manager used to manage the blade servers is installed on the fabric interconnects. This allows IT staff to manage all of the blade servers in a system from a single instance of the UCS manager. This is a benefit over the C-Series rack-mount servers, which are managed through the SIM-C instances on each individual server. Like the VBlock System 200, the VBlock System 320 and VBlock System 340 use two Cisco Nexus unified switches when unified networking is selected. Remember that a unified switch has fiber channel ports to support SAN for block-level storage, and Ethernet ports to support the LAN, file-level storage, and connectivity to the customer's site network. Over fiber channel, the unified switches connect directly to the storage processors in the EMC VNX for block-level storage. Note that some, but not all, VNX models in the VBlock System 320 and VBlock System 340 utilize disk processor enclosures. Recall that DPEs are enclosures that contain both storage processors and some storage drives. VBlock systems with VNX storage can have a number of disk array enclosures, or DAEs, to hold additional drives. Adding unified storage to a VBlock System 320 or VBlock System 340 requires the addition of data movers, which are sometimes referred to as X-blades. The data movers are file servers which provide and manage file-level storage. Note that each data mover is connected to both Nexus switches as well as to both storage processors within the EMC VNX. Now let's talk about segregated networking. For VBlock System 320 and VBlock System 340 models with unified storage but segregated networking, the two Cisco Nexus network switches used for unified networking are replaced with two separate Cisco MDS SAN switches and two Cisco Nexus LAN switches. Unlike the unified switches, which have both fiber channel and Ethernet ports, the SAN switch offers only fiber channel, while the LAN switch has all Ethernet ports. The SAN switch is dedicated to block-level storage traffic over the system's SAN. The LAN switch is dedicated to Ethernet, supporting file-level storage and connectivity to the customer's site network. While unified networking can be less expensive with certain port counts, a segregated network provides better value when the port counts are higher. The last configuration we'll discuss here is segregated networking with block-level storage only. These VBlock system models maintain the two Cisco MDS SAN switches for dedicated fiber channel traffic and the two Cisco Nexus LAN switches for Ethernet network traffic. However, these systems do not have data movers in the EMC VNX and therefore do not support file-level storage.
Now that you have a basic understanding of the VBlock System 320 and VBlock System 340, let's discuss specifics about the components found in these systems. We'll start with the compute components.
As mentioned earlier, the VBlock System 320 and VBlock System 340 use Cisco B-Series blade servers. Any B-Series blade server offered by VCE can be purchased with these systems. These servers have various numbers of sockets that each hold a selection of multi-core processors. Various blade models have different memory slot counts, and there are memory size options for each slot to provide total capacities and core-to-memory ratios ideally suited to any workload. As you know, blade servers are not directly installed in racks, but are inserted into slots in blade server chassis. These chassis can hold 8 half-width blades, 4 full-width blades, or some combination of the two. 2 fabric extenders in each chassis provide the connectivity between the blade servers and the fabric interconnects. Each chassis has redundant power-in cooling components to achieve high availability, and each VBlock System 320 and VBlock System 340 must have a minimum of 2 blade chassis installed. Fabric interconnects provide connectivity from the system compute to the networking and storage components. Fabric interconnects are configured in pairs for high availability. There are specific but similar bare metal rules for each VBlock model. One notable rule is that bare metal servers cannot share storage drives with virtual workloads.
Now let's turn our attention to the VBlock System 320 and VBlock System 340 storage components. The focus of this conversation will be the EMC VNX technology.
Like the VBlock System 200, the storage components of the VBlock System 320 and VBlock System 340 are EMC VNX storage systems. Both EMC fully automated storage tiering FAST and fully automated storage tiering cache Fast Cache are available to customers. Click these links for more information about these products. VNX storage provides centralized management, is optimized for virtual applications, and supports a broad selection of storage drives. The VBlock System 320 uses the VNX 5300, VNX 5500, VNX 5700, and the VNX 7500. The maximum drives each can hold range from 125 drives in the VNX 5300 to 1000 drives in the VNX 7500. All models support SAS, nearline SAS, and EFD drives. All of these VNX models have 2 surface processors with a range of system memory, as you can see here. The Fiber Channel Protocol supports the block-level storage. For file-level storage, these VNX systems can accommodate between 1 and 8 data movers, or X-blades, with a range of memory options per X-blade. The NFS and CIFS protocols support the file-level storage. The VNX models used in the VBlock System 340 are new designs with similar but higher performing components that can support greater capacity. The VBlock System 340 uses the VNX 5400, VNX 5600, VNX 5800, VNX 7600, and VNX 8000. The maximum drive count varies from 250 drives in the VNX 5400 to 1500 drives in the VNX 8000. All models support SAS, nearline SAS, and EFD drives. All of these VNX models have 2 surface processors with a range of system memory. The Fiber Channel Protocol is used for block-level storage in all of these systems. For file-level storage, These VNX systems can accommodate between 1 and 8 data movers or XBlates with a range of memory options. The NFS and CIFS protocols support file-level storage. Here is a list of the storage drives and RAID configurations supported by the vBlock System 320 and vBlock System 340. In terms of drives, these systems can use enterprise flash drives, SAS drives of various speeds and sizes, and nearline SAS drives. RAID configurations available for physical storage drives include RAID 1+0, RAID 5, and RAID 6. For virtual pools, mixed RAID configurations are available, and each tier of the thin pool can have a different RAID protection level.
We've discussed some details about the vBlock System 320 and the vBlock System 340 compute and storage layers. Next, we'll turn our attention to the components that constitute the network layer in these systems.
The Cisco Nexus switch is found in the vBlock System 320 and vBlock System 340. One notable thing about this switch is that it serves as a LAN switch in systems with segregated network and is a unified switch capable of supporting both Ethernet and fiber channel in a unified network. These switches can accommodate both fiber channel ports supporting the vBlock system's SAN as well as Ethernet ports for LAN network traffic. The Cisco MDS SAN switch is only included in systems with segregated networking. This switch only carries network traffic dedicated to the SAN and has only fiber channel ports. The Nexus 1000V is the virtual network switch included in the vBlock System 320 and vBlock System 340. It is the only virtual switch that is covered in VCE core support. Customers can choose to use a different virtual switch, but the Cisco Nexus 1000V is the standard and only virtual switch found in the release compatibility matrix. This virtual switch is used to provide connectivity between the virtual machines running on the vBlock system and from the virtual machines to the physical network. Virtual Supervisor Module, or VSM, is the control software on the Cisco Nexus 1000V virtual switch. It runs on a virtual machine and is based on Cisco NXOS software. Virtual Ethernet Module, or VEM, is part of the Cisco Nexus 1000V that actually switches the data traffic.
So far, you've learned about the hardware components that make up the vBlock System 320 and the vBlock System 340 compute, storage, and networking layers. Now we'll talk about the virtualization technology in these systems.
vBlock System 320 and vBlock System 340 come with a number of ESXi host licenses. These hypervisors are typically deployed in cluster configurations. VMware vSphere is the virtualization platform that provides the foundation for the private cloud. When deployed in a clustered configuration, these hypervisors support the pooling of resources. As you learned earlier, ESXi hosts in a cluster share data LUNs. This simplifies management tasks and makes it easy to move a virtual machine from one physical server to another while the virtual machine is running. VMware vCenter Server comes installed on the vBlock System 320 and vBlock System 340. It provides management functionality such as for cloning virtual machines and creating templates that can be used to create additional VMs. vCenter also manages both VMware vMotion and VMware Storage vMotion. Click the links if you want to learn more about these products. vBlock systems come with the ability to use DRS and VMware vSphere 8J clusters. VMware Update Manager provides information and tasks for vCenter upgrades and patch management. SQL Server is the database backend for vCenter. The database runs on a separate virtual machine from vCenter for performance and portability.
The last topic in this section of the training addresses the vBlock System 320 and vBlock System 340 system management.
All VBlock System 320 and VBlock System 340 models require a physical amp, and the purpose of the amp and the software installed on it is to manage the VBlock system and all of its components. Remember from the management section in Module 1 that there is more than one amp configuration available to provide the right balance of cost and reliability for each customer. All of the management tools installed on the amp are installed onto virtual machines specifically created for each management software tool. As we discussed earlier, a key differentiator to the VCE VBlock system over other cloud appliances is the Strategic Advanced Management Pod, or AMP. Unlike the smaller VBlock systems you learned about, the VBlock System 320 and VBlock System 340 has a physical AMP. The management software that is installed on the VBlock System 320 and VBlock System 340 AMP is listed here. Take a moment to review the list and click on any of these links for more information.
This is a learning check that provides an opportunity for you to assess your progress.